So in this video we will be discussing about how to create geometry in ETABS. So when you open ETABS, you will receive a home page like this. So it is developed by computers and structures. Initially it is released in the year 1970s. So its capabilities are building model. You can model 2D and 3D structures. You can analyze buildings for static and dynamic loads. So you can conduct design of steel, concrete and composite structures. So it is used for high-rise buildings and commercial complexes. So when you open new model, so first you select use built-in settings. So display units as SI, region for default materials Indian, steel section database Indian, steel design code IS 800 2007, concrete design code, so it is IS 456 2000. So click on OK. So then it will all ask you to create grids. So initially you first select blank, because I want to explain you about ETABS graphical user interface. So first you select blank. See here, so this is your main title bar. Main title bar, and these are your toolbars. This ribbon as well as this ribbon are your toolbars. So this space is for Model Explorer. So and this will be menu bar. So menu bar will be just below the main title bar. So this window will be display title tab. So this will be display title tab, and this will be your ETABS status bar, and this one be your global axis. Global axis. See here, this is your global axis X, Y, Z. So X and Y are along the plane and Z will be out of plane. Okay. So here you have coordinate system. Coordinate system, and this will show your current units. Okay, so this is the brief introduction about ETABS graphical user interface. So we will discuss in detail in case of modeling. So in this class I will be demonstrating how to model your columns, beams. If possible, we will model slabs also. So geometry in ETABS includes, so whenever you create a geometry in ETABS, it include first grid system, next story data, next it will be defining your materials and defining your sections. Next, last part will be draw columns, beams and slabs. So today we will be discussing all these points: how to create grid system, how to create story data, how to define materials and sections, and how to draw various structural elements like columns, beams and slabs. So all are included in geometry. So whenever you start a new project, first you click on File, New Model, use built-in settings with metric SI, Indian, steel section database Indian, steel design code IS 800, concrete design code IS 456. You just click on OK. Yes, in grid system, here I have a small example. See here. This is the model. I am going to create it in ETABS. See here. Initially grade of concrete M25, grade of steel FE 500. My column sizes 300 into 500 mm column sizes, and beams 200 into 500 mm. Again I have two types of beams here. So second will be 200 into 600 mm. So if you observe here, my vertical beams are, these beams are 200 by 600. 200 by 600 vertical beams. If you take horizontal beams are 200 by 500. So these horizontal beams are 200 by 500. So slab thickness, I will consider 150 mm slab. Floor to floor height 3 meter. So number of floors, so it will be G plus 3. Okay, so I will be modeling this structure in ETABS. So if you see here, you have these vertical grid lines A, B, C, D, and horizontal grid lines 1, 2, 3. The distance between A to B 3 meter, B to C 4 meter, C to D it is 6 meter. Again, distance between 1 to 2 7 meter, 2 to 3 it is 5 meter. In horizontal direction you have 4 grid lines. 4 grid lines. A, B, C, D. In vertical direction, you have 3 grids. 1, 2, 3. Okay. So this is your problem statement. I think I have the elevation also. No, I don't have the elevation, just I am having plan. Okay. So open ETABS. Number of grid lines in X direction. See here, 1, 2, 3, 4. So 4. Number of grid lines in Y direction. So in Y direction 1, 2, 3. So you just enter here 3. Next, spacing of grid lines. You don't worry about these two now. So go to custom grid spacing. Go to custom grid spacing. So edit grid data. So here you select rectangular grids. In rectangular grids, you select display grid data as spacing. So in horizontal direction, what is the first spacing? 3, 4, 6. So it will be first 3, next 4, next 6. So in vertical direction, so it is 7 and 5. So in vertical direction, it is first 7 meter, second 5 meter. So in vertical direction, it is first is 7 meter and second is 5 meter. So last grid, it should be 0 only. See here, accordingly, it will change the grid pattern. So just click on OK. Here number of stories. So I think it is G plus 3. So G plus 3 means, so it will be like this. So this is your footing top. This level is footing top, or we call it as base or top of footing. Okay. Next level you have ground. Next you have first floor. Next you have second floor. Next you have third floor. Then last one will be roof. Okay. So here number of stories. How many stories you have? So ETABS will consider as this has also one story. 1, 2, 3, 4 and 5. So number of stories here 5. You just enter it as 5. So again, typical story height. So all the stories are 3 meter. So this one also be 3 meter, 3 meter, 3 meter. Again it is also 3 meter. So all the typical story height, it is 3 meter. Bottom story height. So ETABS, it will consider so this story as bottom story. So in ETABS, this will be treated as your bottom story. So here height of the bottom story, it will be 3 meter only. Okay. Then you click on custom story data. Go to edit story data. See here, first one is base. Above the base you have you have ground, next first, next second floor, next third floor. So last one will be roof. So height of each story is 3 meter. Height of each story is 3 meter. So what is the total height of the building? So you have 5-story. Height of each story is 3 meter. So total height of the building will be 15 meter. So this total height of the building 15 meter. See, here we have 15 meters. Okay. So I will take this master story and similar story in the next session. Okay. So this is about story data. So click on OK. OK. You just close this model explorer and you close this 3D view also. So now you are in plan. So you can see the elevation also. See the elevation. First you have base. Base, this is your 0 meter. Ground 3 meter. First it will be 6 meter. Second 9 meter. Third 12 meter. Roof it is 15 meter. Okay. So you can check in plan. Go to base, apply. So base, see here. Base Z coordinate will be 0. Next you select move up. Yes, ground Z value 3 meter for ground floor. For first floor Z value 6 meter. For second floor Z value 9 meter. For third floor Z value 12 meter. For roof Z value 15 meters. Okay. So you can change the grid color also. So either you want, if you want, you can change this grid colors also, and you can change the bubble size also. So for which you go to edit stories and grid system. So this is your story data and this is your grid system. So grid system, you go to modify. Yes, here you can change the bubble size. So I will decrease to 750. You see here, you see the change here. So 750, and I will change the grid color. I will use red color. Okay. You just click on OK. So at the time you click refresh view, you may notice the change here. Refresh view. See here, the grids are changed to red color and bubble size also decreased. Okay. You can increase the size of this dimension lines. So here 3 meter, 4 meter, 6 meter, your horizontal grids, your vertical grids 7 meter and 5 meter. So you go to options, graphic preference, maximum graphic font size. You just increase it 12. Okay. See here, these dimensions are increased. So in ETABS, so this will be your origin. So this will be your origin. So from left to right, your grids are named as ABCD. It is the default settings. From bottom to top, your grids are named as 1, 2, 3. Okay. So you can change the settings also. You can place the grid, these grid ABCD. If you want, you can place these grids here also, or you can place these grids, grid nomenclature on both sides also. So for which, so again you go to edit stories and grid system. You go to modify show grid data. See here bubble location, you can, if you select both, so here bubble location, you select both, on both sides you will get bubbles. Okay, refresh view. See here. So at the bottom also your grids are named as ABCD. At the top also your grids are named as ABCD. At the left side 1, 2, 3. At the right side also 1, 2, 3. So you can change this according to your project requirements. Clear? So this is about creating grids. So grid system in ETABS and story data. So now I completed grid system, and story data. Okay. So you can create another view also. So you go to window list, add new window. See here, at the same time you can work with two windows. In one window you can refer the plan, in another window you can work with elevation. See here. So this is your elevation: base, ground, first, second, third, and roof. You can create n number of views like this. So to activate this window, you just click on this and you take elevation. To activate this window, you just click on this window, you go to plan, you select any location. See here. So this is the plan view at ground floor. So Z coordinate will be 3 meter. So here this is elevation view along grid A. So this is your grid A. So elevation view along grid A. Clear? So here the structure is G+3. How to add another story? Same. You go to edit stories and grid system. Here you go to story data. See here. You just click add story, keep existing story height. You will get the same height as 3 meter. You just click on this. Story height 3 meter. Number of added stories 1. Insert above the roof. So just OK. See here. You have created another story here. You can see the same in earlier it was up to roof. Now it is created one new story. That is named as story 1. Okay. If you want to delete, you can delete this. You just select this, delete story. You just delete existing structure at story. Click refresh view, okay, refresh view, okay. See here. So like this you can add any number of stories and you can delete any story. So next we will be discussing about defining the materials. So next we will discuss how to define the materials. So I will close any one of this window. Okay. So in the beginning I assumed grade of concrete as M20 and grade of steel, that is Fe 500. Fe 500. So now I will show you how to define the materials. So first you go to define material properties. There will be some default materials, you don't worry about that. So go to add new material. So region Indian, material type, first it is concrete, standard Indian, grade of concrete. So you need M25. You just click on M25. Okay. See here, M25. So here you can change this material name. So according to your requirement. So here weight per unit volume. So this is nothing but your density. So density of concrete is 25 kilonewton per meter cube. Okay. So I will change this to 25. Next, modulus of elasticity. Modulus of elasticity or Young's modulus. So it will be 5000 root FCK. So 5000 root FCK. So 25. So it will be so 5000 root FCK 25. So it will be 25000. So Young's modulus 25000. Okay. Next, Poisson's ratio. It will be 0.2. Coefficient of thermal expansion 0.000013. Let it be the default value. Shear modulus. So for our design purpose, I think we use only density and modulus of elasticity. Other values are not used in calculations. So I am mainly concentrating on density of concrete and modulus of elasticity. So you use the default values, Poisson's ratio, coefficient of thermal expansion and shear modulus. So either you can calculate the shear modulus also. So you know the basic formula, shear modulus G equals Young's modulus divided by 2 into 1 plus mu. So here E is Young's modulus, mu is Poisson's ratio. You can calculate and use this shear modulus value, or you can go with the default. Okay. So next it will be modify show material property design data. So here grade M25 concrete cube compressive strength, that is FCK. It will be M25 MPa, megapascal. So here MPa and Newton per mm square both are same. So 1 MPa equals 1 Newton per mm square. So if it is 25 MPa, so then it will be 25 Newton per mm square. So you click on OK. OK. See here. You defined a new material, that is M25 grade concrete. Next, we will define Fe 500 steel. So for which you click to add new material, Indian material type. So here you should select rebar. So you need 500. So HYST grade 500. OK. So here density of steel. So density of steel, I think it will be 78.5 kilonewton per meter cube. I will change this to 78.5. So 78.5. Okay. Next, modulus of elasticity. So it will be 200 kilonewton per meter square. I think it is in IS 456. This value, it is defined in IS 456. So you can refer IS 456 2000, page number 15, clause 5.6.3. So 200 kilonewton per meter square. It can be taken as 2 into 10 power 5 Newton per mm square. So here it is correct. Next, coefficient of thermal expansion. So let it be default value. Okay. Next, click on modify bar, show material property design data. So here minimum yield strength for 500, it is 500 MPa. So use minimum yield strength as 500 MPa. Other values are not used in calculations. These minimum tensile strength, expected yield strength, expected tensile strength are not used in calculations. So let it be default values only. So click on OK. OK. See here, you have two materials. One is M25 concrete and HYST 500. So similarly, you can create or define any grade of concrete or any grade of steel. So this is about defining the materials. So whenever you create or define materials, you just ensure click OK. If you click cancel, whatever you created, defined the materials, it will be deleted. Okay. So now we created the materials. So next we will be defining our columns and beams. So next part will be defining columns and beams. First we will discuss beams here. So first we will discuss general guidelines for beam sizes. So width of beam. So generally it is 200 millimeter or 230 millimeter or 300 millimeter are more common in practices. So width of beam. Okay. So beam overall depth will be decided based on L by D ratio. So for which you use L by D ratio 10 to 12. For this is for simply supported beam and for continuous beams. So your beam overall depth equals span of the beam divided by 10 to, so depth equals L by 12. You fix the overall depth of the beam in this way based on L by D ratio. So for cantilevers, so this condition is valid for simply supported beam and continuous beam. For cantilevers, you can adopt lower ratios. You can adopt lower ratios. So it will be for cantilevers, it will be around L by 10 to L by 8. Okay. So next, according to IS 13920 2016, so page number 4, clause 6.1.1, beams shall preferably have width to depth ratio of more than 0.3. So beams shall preferably have width to depth ratio of more than 0.3, which means width B divided by depth D. This ratio should be greater than 0.3. So according to this code, you should select a beam sizes in this manner. So next criteria will be beams shall not have a width of less than 200 mm. So width of beam should not be less than 200 mm, which means you cannot provide a beam width of 150 or 180. So minimum width of the beam should be 200 mm. So it is as per IS 13920 2016. So page number 4, clause 6.1.2. So first let me check these clauses. So IS 13920, first page number 4. So I will remove this. So page number 4. Yes. See here. Beams shall preferably have width to depth ratio of more than 0.3, which means ratio of width to depth, it should be more than 0.3, and beams shall not have a width less than 200 mm. So minimum width of the beam, it should be 200 mm. Next, we shall see the guidelines for columns. So first criteria is the cross-section aspect ratio shall not be less than 0.4. So see here, this is as per IS 13920 2016, page number 7 and 8, clause 7.1.2. The cross section aspect ratio, which means smaller dimension of the column divided by large dimension. We call this ratio as cross section aspect ratio. We call this ratio as cross section aspect ratio. So this cross section aspect ratio should not be less than, this ratio should not be less than 0.4. So page number 7 and 8. Yes. Clause 7.1.2. I will remove this. See here. This clause 7.1.2. The cross section aspect ratio, that is ratio of smaller dimension to larger dimension of the cross section of a column or inclined member shall not be less than 0.45. For vertical members of RC buildings whose cross section aspect ratio is less than 0.4 shall be designed as per the requirement of 9. Okay. You just remember this clause. The cross section aspect ratio shall not be less than 0.4, which means you should select a column size. It should satisfy B by D ratio greater than 0.4. Okay. So these are the some of the general guidelines for beams and columns. Okay. So if you open your AutoCAD plan, so column sizes here 300 by 500 mm. So here column sizes are 300 by 500 mm. So first I will define column size. So you go to define section properties. Columns and beams are represented as frame elements. For defining columns and beams, we would be using frame sections. You just click on this. You go to add new property. So your column size is rectangular section. So in the property name, if you are defining columns, write C in the property name. So column, C stand for column. What is the column size? 200 by 500. So 200 into 500. So your grade of concrete, so here it is M25. So your grade of concrete M25. Next, section shape concrete rectangular. Depth of the column, it is 500. Width of the column, it is 200. Okay. Next, you go to reinforcement, modify bar, show rebar. See here, whenever you model columns, so design type would be this one. P, M2, M3 design for columns. In ETABS, columns are designed for axial forces and biaxial bending. So this P refers axial force. This M2 and M3, M2 and M3 are biaxial bending. So whenever you model your columns, you should select design type as P, M2, M3 design. Okay. So next, longitudinal bars, you use the same grade HYST. Here it is to be changed, HYST 500. Confinement bars 500. So see here, confinement bar means stirrups or shear reinforcement. So this is shear reinforcement. So if you define HYST 500 for stirrups, the ETABS will consider at the time of calculation, ETABS will consider HYST 415 only, because our IS 456 2000 for shear reinforcement, it is designed for this grade HYST 415 only. Even though at the time of modeling, if you define 500, so ETABS will consider HYST 415 at the time of calculation. So next, clear cover for confinement bars 40 mm. See here, I think you should remember this. Clear cover for slabs and walls. So clear cover would be 15 millimeter. For beams it will be 25 mm. For columns it is 40 mm. For footings it is clear cover, it is 50 mm. For a raft foundation, for raft foundations it is 75 mm. So these are clear cover. So these are available in your SP34 or IS 456 2000. So these are very basics. You just go through those clauses. So for columns, clear cover it is 40. Okay. So next, it is very important. See here, number of longitudinal bars along third direction face, number of longitudinal bars along two direction face. See here, if you observe this diagram, you have a column like this. So this is your axis 3, third direction, and this is your axis 2. So number of longitudinal bars along third direction face. So this is nothing but parallel to third direction. parallel to third direction. So this is your third direction, 3. Parallel to third direction means these bars. These bars. So number of longitudinal bars along third direction face, I will use 2. Next, number of longitudinal bars along two direction face. So direction 2 is your this direction. Parallel to this means parallel to this direction 2 means in this direction. So here. So instead of 5, I will choose 4. So longitudinal bar size and area. So here you have various types of diameters. So minimum diameter is 12 mm. I use 16. Corner bar and corner bar size and area. Again it will be same 16. So if you select the diameter of bar, accordingly area will be changed. Confinement. This is your stirrups. So I will use 8 mm dia stirrups. So click on OK. See here, this diagram is automatically changed. So what is the input I have given? See here, what is the input I have given? Number of bars along third direction face, which means I given 2 numbers. So this is your third direction. So parallel to third direction, so 2 bars. So the software will place 2 bars here and 2 bars here. Next, number of longitudinal bars along second direction face. Your second direction will be this direction. So parallel to this direction, how many bars? You have 4 bars. So you have 4 bars. So if I change to 3 and 5, what will happen here? I will change this to 3 and I will change this to 5. So you just observe the change here. So click on OK. See here. So here number of bars are increased. So again go to modify. So see here, value cannot be less than 2. You cannot place 1 here because minimum you should provide 2 bars. So 2, 4. See the change. So click on OK. Okay. So property modifiers. You click on modify bar, show modifiers. So here you use the default stiffness modifiers. So don't change anything here. You use the default modifiers. So you click on OK. So my column size is 200 into 500 mm. OK. See here. In the properties list, you got the new property as column 200 into 500 mm. Next, you need beams. So in beams you have 2 types. One is your horizontal beams, 200 by 500, your horizontal beams, and your vertical beams are 200 by 600. So you go to ETABS, add new property, concrete rectangular. You select beam. First you define 200 into 500 mm. Material M25. So depth of the beam it is 500, width of the beam it is 200. You go to reinforcement. So here design type. So while modeling your beams, you select this one, M3 design only, because in ETABS beams are designed for moments and shear forces. You select this M3 only. longitudinal bars HYST 500, confinement HYST 500. So here this is important. Cover to longitudinal rebar group centroid. So this is very important. See here, you have a beam face, inside you have a stirrup. So you will be placing single layer reinforcement. You will be placing single layer of reinforcement. So cover to longitudinal rebar group centroid. So this will be this distance. So what is this cover? 25 plus this stirrup is 8 mm. Assume these are 12 mm dia bars. 12 mm dia bars, then it will be 12 by 2. 12 by 2. So let me check this. So 25 plus 8 plus 6. So it will be 39. So I will use this as 39 for top bars. For bottom bars also same 39. You click on OK. Okay. So beam 200 into 500 mm. Next you need another beam size, that is 200 by I think 600. So you just click on this beam 200 into 500 mm. Add copy of property. You just click on add copy of property. So beam 200 into 600 mm. So your grade of concrete will be M25, depth 600, width 200, reinforcement 39, design type M3 design only. Just click on OK. Property modifiers, you use default values. OK. See here, your first property is beam 200 into 500 mm, beam 200 into 600, column 200 into 500 mm. You can delete these default values. You just delete multiple properties. You click on these default. Yes, here. Now we have one beam property and one column, 2 beams. You just click on OK. So now you defined material. This part is over. Next, you defined sections. So these two completed. So next we will go to modeling. So next step will be modeling. So in ETABS, always first model columns followed by beams and slabs. So in ETABS, first model your columns, next beams, next slabs. So now I will show you how to model your columns. See here. So first you go to plan, you select ground floor. Click on apply, OK. See here. So now you are at ground floor. So elevation will be 3 meter. So here you have two options, 1 story and all story. So first I will explain all stories. So I will create one more window. So add new window. See here. So this is your plan and this is your elevation. Okay. First I will show you how to create your columns. So click on this option, quick draw columns. In bracket, it is plan and 3D. You click on this. You select the property. So your property is column 200 by 500 mm. Column 200 by 500 mm. So you just open your AutoCAD file. All the columns are vertically oriented. If you observe this example, so all your columns are vertically oriented. Okay. So this is simple example. See here. At the time you select the property. So here you see the mouse cursor. The column is oriented in opposite direction, but you need it in vertical direction. So for which you go to angle degree. You just change this 0 to 90. Now see here. Now the column is vertically oriented. You just click on this. Wherever there are columns, you just click on those grids. See here. First A1, B1, C1, D1. Similarly A2, B2, C2, D2. Next similarly A3, B3, C3, D3. See here. You just click on this. So it is visible. Grid point A1. Grid point A1. Next you click B1, C1. So similarly you can create the columns. See here. I have placed all the columns. So these are your columns. So in the elevation also, you see the columns. See here. These are your columns. So whenever I select this all story, whenever this select this option all story, so if you create a column in one story, so same column will be replicated on all stories. Same column will be replicated on all the stories. Okay. If you select one story, here, the column will be placed on that story only. If you are place column at ground floor, so that will be on ground floor only, not copied to remaining floors. So this option is very important. All stories, one story. So you just close this window. Okay. So here you have 3D view. So just click on extruded view. So these are your columns. So placed on all the floors. You can change the color also. So for which you go to options, graphic colors, display. Here you have columns. Instead of, I will select red. Okay. See here. So all the columns are in red color now. You can change the background also. You Here now the background is white. You can change this to any other color, for which go to options, graphic colors, display. You select this one, screen, white background, instead of which you select black. Okay, see here. So the background will be changed. Options, I will use the white. Graphic, sorry, options, graphic colors, display, I will use white. Okay, plan, ground, apply. Okay, see here. So how to delete this column? How to delete this column? So just you select this. See here, 6 joints, 5 frames selected, because your this option is all stories. If you select here, the same column will be selected on all floors. Okay, so I will explain this with the 3D view. Add new window. See here. So I will select elevation 1. So in elevation 1, see here, in plan I will select this column B1. See here, in the elevation all the columns are get selected. You just click delete. In keyboard you just click delete. So this column is completely deleted on all the floors. Okay, so how to bring it back? Just in keyboard you press Ctrl Z. Okay, if my option was one story, see here, now what will happen? I will select this column B1 and I will press enter, press delete. See here, this column only highlighted. The column which is in ground floor, that is only highlighted. You press delete in keyboard. See here, only this column gets deleted. So how to bring it back? Just in keyboard press Ctrl Z. Okay, so go to plan, ground, apply, close. So you select all stories. So you select all the columns. See here, 12 joints, 12 frames are selected. So here you have all story. You select all story here, you select all the columns. So you just delete. So I will show you once again how to draw columns. You just have plan view. You go to this option, quick draw columns. You select the property, column 200 into 500. You click on these grids. How to change the orientation of the column? You just change the angle. You just change the angle to 0. See here. So if you give 45 degree, you will get inclined column. See here. If you give 30 degree, see here. In the 3D also you will get same orientation. So these are vertically oriented columns. and these two are horizontally oriented columns, and these are inclined columns, inclined at plan. Same, you should select all stories, select all the columns, and you press delete. You can create circular columns also. So for which you first need to define the section. Go to define, section property, frame section, add new property. So instead of rectangular, you select circular. So column 300 mm dia. Okay, grade of concrete M25, diameter of the column. So you change this to 300. So here for columns P, M2, M3, HYST 500, HYST 500. So reinforcement configuration, circular, confinement bars. This is ties. If you are using stirrups, then you should select ties. So ties are discrete and closed loop reinforcement bars arranged around the longitudinal bars. You should know the difference between ties and spirals. So if you have a ring like structures or bars like this, so these are ties, your stirrups. Okay, so then you have a longitudinal bars like this. You have corner bars like this. These are your stirrups. So these stirrups may be rectangular or circular. You can create circular stirrups also. You can create circular stirrups also. But spirals are like this. So if you have a main bars, longitudinal bars like this. Okay, so spirals are continuous helical reinforcement bars. So these are spirals are continuous bars like this. They are placed like this, continuous. They are continuously placed. Okay, so wounded around the longitudinal bars. I think you can see this type in metro pillars. Metro pillars. You can observe this type of spirals. So these ties are in building columns. These are very common in buildings. So here confinement bars, ties, clear cover 40, number of longitudinal bars, let it be 8, diameter I will use 12 mm, stirrups 8 mm, you click on OK. OK. Now we have circular column 300 mm dia. Press OK. You go to quick draw column. Here property, you change the property. So circular column C 300 mm dia. See here. Now we will get circular columns. You can create any shape. You can create, see here, in 3D view. In 3D view it is circular type of column. You can create L column, L shape or T shape. So go to plan, ground. See here. So one more thing. So at the base level, whenever you click on plan and go to base level, see here, At the base level, ETABS will have a default option for the supports as pinned. By default, if you have a 3D, add new window. So 3D, on what grid have these columns? I think grid C. I will select elevation along C. See here, at the base level, so go to elevation C. So this is elevation view along grid C. This is my plan at second floor. Okay. At the base level, ETABS will have a default option for supports as pinned. So you can change pinned to fixed support. You can change this support condition. See here. By default, ETABS will have a option for supports as pinned. You can change this to fixed. So for which you go to plan view, you select base, you select all the columns, So while assigning the support, see here the option should be one story only. Here the options should be one story only. Otherwise you will get support at all the nodes. Whenever you creating the supports, your story option should be one story. Okay, so I will select all these columns, all 4 columns. So one story, you go to assign, joint, restraint. So see here, first condition is fixed, apply, okay. See here, now it is changed to fixed support condition. Okay, so I think I completed the modeling of columns. I will show you any other shape. So T or L shape, define section property, frame section, add new property. See here, you can create concrete T section. Your column, I will property name as T column, grade of concrete M25, section shape concrete T. So total depth 750, total width. So here it is very important. So total depth. So this is your overall depth. So it is 750 mm. Total width. So this will be your width of column, 750 mm. Flange thickness. So this will be your flange thickness. Web thickness at flange. So this is your web thickness. Okay. So just to show you, I will use the default values. I click on OK. So this is your T column. Okay. So modeling, quick draw column. You in property, you select the T column. See here, T column. You change the angle to 90 degree. See here. So this is your T shape column. You just click on this grid point C1. So this is your T-shaped column. So you can view this in the extruded view. See here. So this is your T-shaped column. So plan, ground, okay. So T-shaped column. So how to hide these grids? How to hide these grid lines? So you go to edit. You go to edit. Here, I think not edit, to view. Go to view. Set grid system visibility. See here. Your grid system will be hidden. How to bring it back? You click on the same option. Go to view, set grid system visibility. Again, you can hide this your global coordinate axis. X, Y and Z will be out of plane. Please remember. So this is your global axis, X, Y, Z. So Z will be out of plane in ETABS. So you go to view, you just click on show axis. So this will be removed. How to bring it back? You just click on the same option. Go to view, show axis. So plan, ground, apply, close. Okay, so I completed modeling of columns. In the next lecture I will take up modeling of beams and slabs.